So we can take advantage of aqueous chemical reactions in a variety of ways. We can apply stoichiometry to them. We can also use them in a technique called gravimetric analysis, which is a technique that's based on the measurement of mass of a product, usually a precipitate, that is generated in a solution or in a reaction. Um, And typically, analyses like these involve both the formation and also the isolation of these precipitates. So it's a highly accurate type of technique, and we can take a look here at an example. So it says a 0.8633 gram sample of an ionic compound, and we're told that the compound contains chloride ions. We know it has a Cl minus, and then an unknown metal cation. So we'll call this an X plus for right now. Is dissolved in water and treated with an excess of silver nitrate, and then 1.5615 grams of silver chloride precipitate forms. What is the percent by mass of chloride in the original sample? All right, so we have our ionic compound. We react it with silver nitrate, and what happens is the silver from the silver nitrate and the chloride, these combine to make the silver chloride solid precipitate, and then that is what is measured in this technique, right? So we end up forming 1.5615 grams of AgCl. And then what we're asked to find is, what is the percent by mass of chloride in the original sample, which is the 0.8633 grams. So, and we know that sample has chloride in it because it reacted with the silver nitrate to make the silver chloride. So what we can do is we can use the mass of the silver chloride that we have over here. We can take that and we can calculate the percent by mass of Cl in AgCl, because we can easily do that. This will be the mass of Cl, right, over the mass of AgCl times 100, right? And again, we can just assume 1 mole of this to make the calculation easy. So the mass of Cl there, look it up, it's 35.45 grams. The periodic table, the AgCl is Ag, which is 107.9 grams, plus the Cl, 35.45 grams times 100. Okay, this would give 24.72% the mass of chloride in silver chloride. Well, we have or we generated 1.56 grams of this silver chloride product. So if we take that 1.5615 grams of the of our product and we times it by the percentage of chloride in silver chloride, 0.72. Let me rewrite this here. 1.5615 grams of AgCl. Okay, times the percentage of chloride in it, so 24.72% of Cl. That'll give me then the mass of chloride in this product, right? So if we multiply it out, we see that we get 0.3860 grams of Cl. But where did that Cl actually come from? Well, the Cl in the silver chloride, this would have came from our original ionic compound, right? And we know how much of this we had. We were told that it was 0.8633 grams of that ionic compound that had chloride in it. So then we can calculate the percent of chloride in our original ionic compound would be the mass of the chloride that we calculated, which would be the 0.3860 over the mass of the original ionic compound 0.8633 times 100. Okay, and then that's going to give us 44.71%. Chloride in that unknown ionic compound. So what we did is we're taking advantage of the reaction of our ionic compound. Let's just say it's XCl reacting with silver nitrate in a double replacement reaction. Right, the X and the Ag are going to swap places with each other. So we end up making, we end up making the nitrate of metal X plus the silver chloride, right? So the chloride that was in this unknown compound actually ends up being in that silver chloride solid precipitate at the end. So that's what we're taking advantage of in these gravimetric analysis.